Hey everyone, welcome back to our channel. So in today's video, we are diving into the world of machine learning and exploring three powerful classification algorithms, k-nearest neighbors and decision tree and the naive Bayes. So today we'll be explaining about the code. So this code is all about the data handling and the analysis. Imports the pandas has PD, imports the pandas library has PD. It uses for the loading and the manipulating the data sets like reading CSV files, handling data frames. So import numpy has NP, import numpy has NP useful for the numerical operations, arrays and the math. Visualization libraries. So import matplotlib. So pyplot has PLT. Used to create the visualizations like line plots, histograms, and the scatter plots. So import the Seaborn has SNS, a data visualization library based on the matplotlib, offering the better styling and the easier plotting like heat maps and the box plots. Pre-processing tools. So from sklearn model selection, import the train test splits and the function to split your data set into the training and the testing sets. From sklearn pre-processing import standard scalar label encoder. Standard scalar standardizes the features by removing the mean and the scaling to unit variance. So label encoder converts the categorical values like male and female into the numerical values. So machine learning models from sklearn neighbors import the nearer classifier, imports the k nearest neighbors classifier. From sklearn tree imports decision tree classifier, imports the decision tree classifier. From sklearn naive Bayes, imports the Gaussian NB, imports the Gaussian naive Bayes classifier. Evaluation matrices. From sklearn matrices imports the accuracy score, precision score, and the recall score, F1 score, and the confusion matrix. So these are the functions used to evaluate how well your model performs their measures. So what is accuracy? Accuracy is how many predictions were correct. Precision means how many predicted positives were actually correct and the positive. So recall means how many actual positives were correctly predicted, and F1 score means the harmonic mean of the precision and the recall. Confusion matrix means shows the number of correct and the incorrect prediction broken by the class. So load the data set. So df is equal to pd dot read CSV means, so this line loads the CSV file named in the mal customers CSV into the pandas data frame called df. So PD read CSV is a function used to read the CSV, that is comma separated values files. So this path is suggested to file is located in the working directory of Google Colab or the similar environment. So display the first five df. So display the first five rows of df.head. So df.head returns the first five rows of the data frame. It's oftenly used to preview the data, including the column names and the sample values. Output of df.head might look like this: customer ID, gender, age, and annual income, and the spending score from 1 to 100. So the here customer ID is 1, and male is the gender, 19 is the age, and annual income is 15,000, that is 15K, and the spending score is 39. Second is customer ID is 2, male 21 years, age and 15 K salary, and spending score is 81. So next will be continued by Rohini Kids.
Encoder is equal to label encoder. It creates an instance of label encoder from a scalar with used to convert the string labels like male and female into numbers, example 0 and 1, which are required for most ML models. df gender is equal to encoder dot fit transform. df gender transforms the gender column by encoding it female 0, male 1. The encoded result replaces the original gender column in the data frame. X is equal to df gender, age, annual income, spending score 1 to 100. Selects the subset of columns from an subset of columns from the data frame to used as a feature sets for training the model. These features are gender, now numeric 0 or 1, age, customer age, annual income in the thousands of dollars, spending the score 1 to 100, a score assigned to the customer based on their spending behavior. Def spending category score. If score is less than or equal to 33, return low. L if score is less than or equal to 66, return medium. Else return high. Defines the function that takes the spending score 0 to 100 and returns the spending category 0 to 33 low, 34 to 66 medium, 67 to 100 high. This simplifies the continuous spending score in the category target for classification. DF spending category is equal to DF spending score 1 to 100 dot apply spending the category, applies the spending category function to each value in the spending score 1 to 100, stores the result in the new column called spending the category. Now each customer is labeled as low, medium or an a high. DF spending category is equal to encounter dot fit transform DF spending category uses the same label encoder to convert the low, medium and high into the numerical values low 1 or 0, medium 2 or 1, high 0 or 2. Actual numbers depends on the alphabetical order since the label encoder encodes in the graphic order. Defines the target variable y is equal to df spending category, assigns the newly encoded spending category column to y is the target variable that the model will be learned to predict. Normalize the features. Scalar is equal to standard scalar. It creates an instance of standard scalar from a scalar dot preprocessing. This scalar standardize the data by removing the mean and scaling to the unique variance. This is important for algorithms like KNN and SVM that are sensitive to the feature scales. X underscore scalar is equal to scalar dot fit underscore transform X. Applies the scalar to the feature matrix X. Fit the transform, first calculates the mean and standard deviation for each feature, then transforms the data. The result x underscore scaled contains the normalized features value centered around 0 with standard deviation 1. X train x test, y train y test is equal to train underscore test underscore script x underscore scaled y underscore test size is equal to 0.2, random state is equal to 42. From the scalar model selection, import a train underscore test underscore split x underscore train x underscore test y underscore train y underscore test is equal to train underscore test underscore split x underscore scaled y comma test underscore size is 0.2, random state 42. Train underscore test underscore split randomly splits the data into x underscore train 80% of the feature for training, x underscore test 20% of the feature testing, y underscore train corresponding labels for training, y underscore test corresponding labels for testing. Test underscore size is equal to 0.2 means 20% of the data is used for testing. Random underscore state is equal to 42 ensures the reproducibility of the split. Final corrected block scalar is equal to scalar standard scalar x underscore scaled is equal to scalar dot fit underscore transform x. Split the data set into training 80% and testing 20% from the scalar dot model selection. Import the train underscore test underscore split x underscore train x underscore test y underscore train y underscore test is equal to train underscore test underscore split x underscore scaled y underscore test underscore size is equal to 0.2, random underscore state is 42.
Next will be continued by Shreyas.
Now we will see this code line by line, fixing the errors and explaining each part clearly. First one, train n nearest neighbors, k, kn neighbors classifiers, knn dot fix n equal to knn dot predict x test. It creates a knn classifier instance, knn neighbors classifier, and it trains with the training data fit x train y train and it predicts the labels for the test data KNN predict, and it results the widespread KNN contains the predicted spending categories. Second one is train decision tree classifier. dt equal to decision tree classifier dt dot fit x train y train pred dt equal to dt dot predict x test. It means creates a decision tree classifier and it trains with a fit, makes prediction on the test set with predict, and it result in the stored in y pred dt. Next, third one is train navy based classifier. NB equal to Gaussian NB dot fit x train y train y pred NB equal to NB predict x test. It means it uses the Gaussian naive based probabilistic classifier, trains a model and predicts on the test data. Next, we will see about the def evaluate model y test y pred model name printf n model name performance printf accuracy score y test y pred 2f printf precision score y test y pred average equal to weighted 2f printf recall score y test y pred average equal to weighted 2f. Next, printf f1 score y test y pred average equal to weighted 2f. It means a custom function to evaluate model performing using common classification metrics. It prints the accuracy percentage of the total correct prediction, precision percentage of the predicted positive that were actually positive, recall percentage of actual positives that were correctly predicted, F1 score balance between the precision and the recall. Summary of the model trend is KNN classifier, decision tree, and navy base.
Evaluate the model performance. Evaluate underscore model y underscore test y underscore prediction underscore KNN k nearest neighbors. Evaluate underscore model y underscore test comma y underscore prediction underscore dt decision tree. Evaluate model y underscore test y underscore prediction underscore nb naive base. Explanation. Each model performance is evaluated using accuracy, precision, recall, and F1 score. These metrics helps us understand how well the model is predicting the spending category of each customer. Evaluate underscore model is a custom function that prints these metrics in a readable format. Visualize confusion matrices. Figure axis is equal to PLT dot subplots 1, 3. Figure size is equal to 15, 5. Create single row with 3 plots, one for each model. Model is equal to K nearest neighbor Y prediction underscore KNN, decision tree Y prediction underscore DT, naive base Y underscore prediction NB. Stores each model prediction in a dictionary for easy looping. For AX, model name Y underscore prediction in zip access model dot items. CM is equal to confusion matrix Y underscore test Y underscore prediction. SNS dot heat map CM not is equal to true. F front is equal to D. CMAP is equal to blues. AX is equal to AX. AX dot set underscore title F confusion matrix model underscore name. AX dot set X label predict label. AX set Y label true label. Loops each model and subplot computers the matrix, a table that shows actual versus predicted. Draw a heat map to visualize how many instances were classified correctly or incorrectly. Add inappropriate titles and axis labels. PLT.type layout. PLT.show. Adjust the layout, displays the confusion matrices side by side. KNN performance accuracy 0.90, precision 0.90, recall 0.90, F1 score 0.90. Decision tree performance accuracy 1.0, precision 1.0, recall 1.0, F1 score 1.0. Neo based performance accuracy 0.97, precision 0.98, recall 0.97, F1 score 0.98. Graph. First one shows the confusion matrix of the KNN. Second one shows the confusion matrix of the decision tree. Third one shows the confusion matrix of naive Bayes. Thank you for watching our video.